Yes. Okay. Welcome back again for the second time in a day. Uh, so before I go to the new image processing lab sheet, do you guys have any questions about the first lab sheet?
Sir, Major Sunil here, sir.
Sir, in question number 2D part.
2D part. Okay. Yes. Um, which one of the above two outputs looks more like what you would expect a monochrome image to look like? Yes. So what is your question there?
Sir, next part.
2D, na? No?
In,
Which one?
in continuation, would you
Wait,
expect a computer vision algorithm? How
one
to?
minute. Which one?
Sir, actually,
Would you
just
expect a computer vision algorithm to work on one better than the other? Justify your answer. Yes. So what is that you are doing? First one is selecting a green channel and you are displaying red channel. You are displaying. Then what else are you doing? Which one of the above two outputs look more like what you expect in a monochrome image to look like? What is your answer? What are your thoughts about that? You can think loud. You can till the point where you uh, till to which you could arrive. So one is red channel and another is a green channel. Which one would look more like the monochrome one?
So the one picture which is having like suppose green.
So let me just see the picture. What is that picture? Is it Vaishnavi? Can you make any comments about that?
Sir?
Can you make any comment about this part D? So in general, I would say for these images, I have not seen myself. See, in general, one channel is not good enough for you. It is typically you take an average of all these three channels, and that would perhaps give you a better conversion from RGB to gray than taking any of a single channel alone. That's what I would expect there. Uh, Vaishnavi, hope that is
Yes,
what
sir.
is expected, right?
Yes, yes. So one actually every channel will have it's like if there is more green in the image, we will have different values in the green channel, right?
Right.
Uh, so actually, I think it is subjective to what image we are looking at.
Right. Correct. See, maybe in the peppers image, I don't remember. I should be having it here. Let me open that. Yeah. See, there is a green pepper here, red pepper here. So what would happen if you are taking just a red channel? Of course, it's not pure red. There will be some element of green also would be coming there, but you would completely miss it out. So what you would rather consider is, of course, a simple averaging. Of course, there are other ways by moving from RGB to some other color space. Okay, HSV, for example, might give you a better representation and then a better conversion. But if here, the way I would answer this is neither R nor G would be a great representation for this image. Perhaps an averaging across all three channels would give you a better representation for a computer vision algorithm to take it forward.
Yes, sir. That's what we meant. It is subject to image, right? Anyways,
Correct, correct.
what we asked is which monochrome image means which channel would represent the best of this color image.
Right, right,
So seeing a color image and seeing a monochrome image. So which one,
right,
which monochrome image will represent better? So it is
right,
subject
right,
to the
correct,
image we are giving. If they
right,
do experiments with two, three more images, they'll understand that.
right. See, again, this would come green, predominantly in green, all those green chilies and green peppers or capsicum, whatever may you call it. On the other hand, this would be in red channel. So which channel is good? Well, this is subjective to which color you have. One simple thing is an averaging is what RGB to gray one conversion is perhaps better than any of them. But if you know in a particular one it is having a specific color, then you could go it in a very subjective special case. But in general, averaging could give you a better result.
Yeah,
Is that
yes.
answering your question, Srija?
Sir, I didn't ask the question, sir. Snehal did.
Oh, sorry.
Yes,
Okay.
sir. It's clear now.
Did that. What your name is Snehal, right?
Snehal.
Okay.
Yes, sir.
Okay. Yeah. Sorry for that. Fine. Yeah. Hope that answered your question, Snehal.
Yes, sir.
Okay. Good. Any
Sir,
other?
I had a question, sir.
Yes, sir.
Sir, the question is that when we say that we want a monochrome image, sir, so a normal RGB image is having width of 3. So let's say the image is Pepper's image, and I want red monochrome. Monochrome means single color.
Correct.
So
Correct.
if I want red monochrome, there are two ways that I get it. One way is that in the RGB the three different arrays which MATLAB is reading, I make the green and the blue array 0, but I read the three arrays together. So that gives me a reddish image, basically.
Correct. Correct. Correct.
And the second way is I take the value of the red array and I convert it. I just copy it to a separate 2D array only with width 1. So
Right.
that gives me actually a grayscale image, sir.
Correct. Correct. Correct.
So in this entire lab sheet, which one were we expected to work with? Were we expected to work with that grayscale 2-dimensional image, or were we expected to work with the 3-dimensional but monochrome image?
Yeah. So, well, you could just selection of green channel typically means you create a grayscale image with that taking that channel. See, it is at the end of the day, it is all that varies is the way you are displaying. That is all it matters. The visualization part is all that is differing. So you could simply take that channel out and just display that as a grayscale image. That is good enough. That means, in other words, see, we still call the grayscale image as monochrome image because it is that grayscale is image is coming from one particular color. That's why you call it as a monochrome image.
And in case we, sir, in case we use that inbuilt function in MATLAB which just converts the image to grayscale, so that it is actually doing nothing but just taking the mean of the intensity values of all the and converting it into a 2D image.
That's right. That's right. That's all it does. RGB to gray, typical, as I was mentioning also earlier, typical way to convert is you take the average across all three channels.
Right. Sir, I have a second question.
Yes.
So the second question is question number 3, sir. Question number, no, not 3, sorry. Question number 4, C and D, sir. Sir, in this, in MATLAB, sir, shifting the image left or above is not possible because that is negative indexing. We can only shift it down or we can only shift it right.
Well,
and
see,
or we use circular shift, sir.
Yeah, that is good. That is good. That's all is expected. You do a circular shift because that perfectly, see, basically you are aware of dealing with the boundary conditions, correct? So in the boundary conditions, you could consider different types of boundary conditions while you are making this shift. One assumption is you have zero boundary condition. Second possible assumption is you have the same boundary condition which is there at the boundary, whichever column is there, that column itself is extending beyond that while you are making the shift. That is another possibility. Third possibility is you could consider that around this edge, the image is getting reflected and you make these operations. And yet I can give you the fourth one also, where you take a circular one. It is like next to the image, you place the same image here so that when it is shifting, this whichever is there at the end would replace this. So you have considered there a circular shift. Even if someone else has considered a different shift, they can mention there that which is the type of boundary condition that they are considering here while they are shifting the pixels.
I think, sir, some of us have just shifted it to the right and subtracted the image. So
Right. You can do it, but you just need to, in that, what does it mean is you are probably assuming a 0 intensity pixels beyond that boundary, because when you are
it'll be black.
shifting it,
Yes. Yes.
exactly. So as long as you mention that, you assume beyond this line you have black, then you put black, nothing, that's fine. Okay, or else the circular shift is a good idea, particularly when you need to also deal with that image in the frequency domain. This will ensure that similar frequencies are retained, and this is not introducing new frequencies when you convert this image from the spatial domain to the Fourier domain. So circular shift in that manner is also good.
All
Okay,
right.
you could do any of these 4 I was mentioning, just that you need to mention which is your assumption and do that.
All right. Thank you.
Good. Any other question? Yeah, any other students have any other queries? Is there still anyone who haven't submitted?
Today is the last day, sir.
Sorry.
Sir, like I think 27th was the last day, sir.
Sir, I am
20.
submitted today.
Okay,
I'll be
27th. Okay, today is the last date. Huh?
Yes, sir. Yes.
Okay, fine. Just make sure you submit it and yeah, do it. So can I move on to the next lab sheet if you are done with this? I'm glad you all guys will be submitting it. Make it a habit.
Sir,
Yeah.
before moving to lab sheet 2, one request from my end.
Yeah,
Like
please.
for those who have submitted the lab sheet, can they get that evaluation today, so that in the next lab sheet we can rectify the mistakes?
Maybe, yeah. What we will do rather is maybe by the end of this week is more realistic, because they need to also go through your reports and give some good feedback. So what we would ensure, or at least try to ensure, is maybe if my TS could find some good time to go through this 12, we'll try to give it by Monday for this lab sheet.
Okay, sir. Okay.
Hope that is fine.
Yeah, okay,
because
sir. Thank you.
there are 13 students are there. They need to look at your output, your code, your report. So 13 into 3, 39 items are there for them. So based on that, they will give you the feedback, which you make sure to incorporate in the next round.
Okay, sir.
If at all there is some learning from there.
Sure, sir.
Good. Any other before I move on to the next part? So how are you guys able to follow the class, all of you? Are there any issues? Is it bit slow? Is it bit fast? Is it okay? So what is your feedback?
As of now, it is fine, sir. It is not fast and it is not slow.
Okay, good. Yeah. Anytime if you have any issue, get back to me. I'll be happy to get your feedback and see in what way there is a possibility to improve that. Okay.
Sure, sir.
Right.
Sir?
Good. Yes.
Like, isn't there any correlation between the classes and lab? Like that things that we
Yeah.
discussed.
See, correct. See, what I will try here is typically I'll try that I don't have to teach something new here in these labs. So if you notice, means anyway, this was already taught in the class, and the second lab is also assignment is given in such a way that if you have attended the classes and you paid attention there, and if you learned that, if you are clear with that, with the minimal add-on, just a small add-on package to have here should be good enough for you to execute this. That is how I plan to do it. It is for the same reason that I'm trying to keep the questions, we are trying to keep the questions also in such a way that if you sit seriously for 3 to 4 hours, you should be able to finish it off. It's not like we don't want to give you a big lab assignment that can take maybe 8 hours or 10 hours. Okay, rather we will make it into small ones. Let's have what we prefer, at least at this point, and later also we try to follow, is that make it small module, don't make it too big. Let there be multiple more assignments coming every week by week, that's okay, but ensure that within this 3-4 hours that they spend on Thursday, the assignment should be such a way that if they are clear with the concepts of the class, they should be able to finish almost 70 to 80%. The rest, maybe 1 or 2 hours on some other day, they could spend to write the report, consolidate all these results, clean up the code, and then submit. That's the idea with which we plan to go. Is that answering your question?
Yes, sir.
Okay,
Thank you,
good.
sir.
Yes. Any other thoughts in this direction from any of you? Right. So I'll go to the lab sheet 2. Now, if you notice, the lab sheet 2 has what has been discussed in today's class. This one is having, for example, the gamma correction problem. You are given a couple of images. Okay. So you need to show the given the inputs. You should write it. You should learn to write functions. Okay. Function will come as a one separate .m file, which you will be calling from your actual program. So that function you should write such that it takes as an input an image. Okay, well, an image means it can be directly the name of the image itself. It's not like a 2D array, but it can take along with it complete path an image and the gamma value which should be applied. And as an output, it should give you an image that has been obtained as a result of this gamma correction. Okay, very simple. This you could write it in 2 lines of code is good enough to write this function and do it, right? This for example, you call your output as, let's say, I just write it here. We have discussed already in the class. C equal to G equal to let's call the original image as, let's say, I. Okay, I. Let me, maybe I'll better G, small letters typically used for vectors. So how do you do that? How is first gamma correction is applied? S equal to C into R to the power of gamma, right? So given an image, now what you should do, you, as I was mentioning earlier, don't do pixel wise operations when you are dealing with images. Figure out how you could apply for the entire 2D image there. Okay, and then will this C vary for each pixel, or is it fixed for an image? For a fixed given image and gamma value, can I find out the C value? Hello? For a given image.
So if we know the gamma value, then we can find the C value, sir.
Right. Sorry, can you repeat?
If we know the value of gamma, then we can find the value of C, sir.
That's right. I give you the image and I give you the gamma. All you need to ensure is what is the role of C there? What is the role of
scaling factor, sir? It is acting as a scaling factor.
That's all. Scaling factor. Suppose if you are using 8 bits to bring it to the range of 0 to 255, that's all you would be using. So figure it out for a, so it will be constant across the entire image. So in one line, you could, one line of code is good enough to implement this. Okay. So slowly start paying attention to the way you code also. Initially getting output is itself is probably your criteria, but as you move on, ensure that are you doing it in the best way, or is there any further scope to improve things? Maybe you might be writing for loops there. It is okay to begin with, but later you should realize it's a 2D image. So can I do it in just one line without no for loop is required here? A single line of code will give you the gamma corrected image here. Okay, that's what has been given here. You should write it. And so this has been asked, apply this transform to both the input images for varying values of gamma. So it's up to you. You take some 3-4, don't ask which values of gamma. One anyway, you know, it will give you the same thing. So there's no point in applying there. So maybe some 2-3 values here, 2-3 values here. You just take 4 to 6 values there. and that are making some reasonable sense for those things. You empirically figure it out and just put there. And from those gamma values that you have empirically picked up and the results that you are getting there, specify your inferences there. Is the first question clear?
Sir, is the gamma correction basically used to change the contrast of the image?
Is used for
Changing the contrast of the image.
correct. That's right. Image enhancement, we call it.
Okay, sir.
This is as we discussed today in the class. Right? Hope this is clear. Hope you remember a couple of images. There is an image of the MR image of the spine where there is a black region where in fact there are some injuries but not visible. Another is an aerial view image that has been taken under a very bright daylight condition. Because of that, you could not really distinguish. So one was the case where you want to enhance the dark region. Other was the case where you wanted to enhance the contrast of the bright region. So accordingly, you would recommend which one is better by understanding how the image looks like. Is that clear?
Yes, sir.
Okay, good. So then the Sindhura and Vaishnavi, please do add if some important point is missing while I'm mentioning about these things. Right.
Yes.
So
Okay.
threshold based segmentation here. Histogram, now you know that. So how could you use a histogram to threshold? For example, there could be instances where you would expect the object and background having distinct intensity distributions. There could be images. This is, of course, will not cover all spectrum of images, but nevertheless, there could be some good number of cases where you could separate them based on this histogram. So here some coins image has been given. You select a suitable threshold there based on this histogram. You see the histogram, you play with it. What would happen if what does it mean by I mean by playing? Let's say you are taking from 0 to 255 each one as one bin. Okay, you see somewhere here perhaps it could be there. So anything below this you make to 0, anything above this you make to 1, or the other way around. So if you look at the remaining ones, they have the assignment is such a way that you want it in a particular way. Okay, so now anything below this intensity, you go through that image and make it to 0, others you make it to 1. Again, to begin with, you may start writing a for loop, but you would realize that you don't really need a for loop. A single statement might be enough to generate an output image where you have this object and background. It's fun. In fact, this is like solving some puzzles. So if you start looking at programming in this manner, you would really enjoy doing such tricks. And it's not just a tricks, I slightly trivialized it, but it's computationally more efficient way of dealing with matrices. Okay, anyways, I don't mind for this program whether you write for loops and all. At the same time, I strongly recommend you, as I was mentioning, to have that instinct to simplify write an efficient code. Okay, so that's what has been given for coins. You are asked to do that. You play with it, you see the output, and accordingly fix the threshold. The second one, there were some numbers in that. Now you were asked to select a suitable display such that these are possible. All the numbers in white and background is black. So what is the threshold that is distinguishing them? And then accordingly create an output image. Now in the output image, you select a threshold and write it in a way that numbers are in black and background is in white. Okay. And the exactly opposite in the other case, you just change what is it that you are going to assign in the output. And you want only few numbers to appear. So again, further play with the threshold values and mention what is the threshold and show us what are the results that you would get there. Okay, that's all, as simple as that. This is about thresholding. So first one is gamma correction, second is threshold based segmentation. Any questions in these two before I move to the last one? Is that fine? Yes. Any, you were asking some question or saying?
Yes, sir. I was asking that suppose we have an image and we are checking the histogram. So histogram just basically gives the distribution of the pixel intensity values, like how many, right, sir?
Correct.
So, but how do we determine that which cluster or which section belongs to which object or something like that from that histogram?
Right. See, in general, it will not work for all images, but once you choose the threshold there, see with that threshold, if you make one part to 0 and other part to 255, what is it that you are getting in that image? What is going into the foreground and what is coming into the background? Write a small piece of code that takes as an input the threshold and displays you the output image. That's all. Then you play with that output.
Okay, sir.
It's by visual inspection you fix here.
Okay, sir.
And
I was
there
thinking
are
from the point of how to automate this
yes,
process, but fine.
yes, there are indeed quite a few ways. I'm not sure whether I'll get enough time to discuss Otsu thresholding. If you are interested, it will be there in my previous lectures that I was mentioning in the slides. Also in medical imaging, I was mentioning L7 to L27. There is something. Is there anything on Otsu thresholding there? Or you could take there are other lectures also. Maybe you just look at Otsu thresholding. Okay, even not necessarily my own lectures. Anywhere Otsu thresholding will tell you that. It will give you information about that. Again, keep in mind Otsu thresholding is not the only way. There are different ways you could figure out what could be the optimal threshold that distinguishes object from the background. Just from histogram, you can do that.
Sir, for this lab sheet, I think even also is not required, sir.
Correct. Just you play with it. Sometimes the
so for the
histogram
first
will be.
So for the first image, they can easily find the threshold.
Right.
For the second, for the B part, the numbers thing, they just have to see which one is suitable. Like
Correct.
the histogram is not like 2 peaks and all these things. They just have to figure out change values and figure out which will be better.
Yeah, don't need to use Otsu here, as Vaishnavi is mentioning. Just to play with that thresholds and see where when you are using that, is the number coming, what is the range. Just try to have some interpretation for the intensities. You should get that trade. Okay, that is the whole purpose of giving you these assignments. So you empirically play with it, see the output, and accordingly figure it out. Manually play with it.
Okay, sir.
Right.
So here we have already mentioned, like for histogram, they have to write their own code. Like don't use the already existing function.
Right. Oh, so write your own MATLAB program to perform global thresholding. And I think initially for histogram, she has mentioned here.
Yeah, so histogram separate
own function for computing hist. Don't use hist there. Okay, it's very simple. Yeah, histogram writing function is also, you just need to say the number of bins that you want. Okay, and in that you should compute once those bins are there. What is it should take as an input, and then how many bins should be used there. Those are with those inputs so you just imitate what the histogram function does, and then you do the counting yourself in that function and then draw. Okay, this drawing should be, then once you know for each value how many should be there, I don't need that aesthetically pleasing same level of sophistication of what hist does. Isn't it, Vaishnavi? If they are able to show even a bar graph, they're good enough.
Yes. So may not be bins also. They can just count the number of pixels for each intensity value, and they can just
right. That part is there. That you write it so that you will really get a feel for how histogram is constructed. Yes. Somebody is asking a question. Someone asking a question. Okay. So hope first two questions are clear with that. So I'll move on to the third one, which I was discussing today at near the ending of that class. Okay. Suppose I have, this is my histogram, where my histogram is from 0 to L-1, let's say. So even for your histogram function, you could consider, they could consider 250 bins, right, Vaishnavi? They can assume that their image has 0 to 255 and do it, correct?
Yes, yes, yes. So I think their histogram won't be till, I mean, 256 maximum value will be less than 256 only. They can stretch it to 0 to 256.
No, I mean for these first two, they could consider their histogram won't be there, but the bin is, each one is of one intensity and 255 bins. Correct, 256.
Correct. Yes, yes.
That is how you write your histogram. Okay, this need not be so sophisticated that you bin length, bin size, and all need to be mentioned. That is not required, because we want you to write it so that you really get a feel for it, on how you count, and of course some expertise in writing this code effectively also. Okay, coming back here, suppose with your histogram you got a function like this. Okay, now this is, let's call this as f min you got, and this, let me call it as f max. Now how can you, if f min has, now what I should do, this histogram, the output I want is this should come here, this should go here, and in between it should linearly stretch. So a linear equation is all that I would require. Okay, so I stopped there and I was asking you in the class to figure it out. But how do you write? Let me call that value as f, for example, any value out of this r, let me call it as f. So to bring f min to 0, what is it that you need to do? F minus
F min.
F minus F min. Okay, so then what would be the range of values in my intensities here? Now what is the range I would get? Earlier they are in the range non-zero values. If I look at it, was earlier F min to F max. Now what is the range now once I do this?
0 to F min minus F max. F max minus F min.
0 to F max minus F min. Okay, now I want to normalize these values to, from here to, I want to take it to 0 to 1. How do I do that?
Divided by, we can just divide the now the new maximum from the entire range.
Right. Now, what is the range of it? 0 to 1. Now, I want this range to go from 0 to L minus 1. How can I do that now?
Multiply into L minus 1. Multiply by L minus 1.
Multiply by
L minus 1.
Right. So when it is F max here, F max minus F min by F max minus F min is 1. That will go to L minus 1. Hope that is fine. And of course, there will be values now, non-integer values, right? So I could take round of this value here just to put it into integers. That's all you have to do here. That's how you would scale it. Is everybody comfortable with this expression, or are there any questions? This is how you do contrast stretching based on the histogram. Hope I wrote the expression correctly. Otherwise, those who know it could correct me. So this is all you are asked here. From the image, you need to just to couple of images were given. For each of those images, you first display input a histogram, and from the histogram, you figure out what is F min and F max, right? And from that, you perform this operation and you get the new histogram, right? And what's the case now? Now you know which intensity got mapped to which intensity. Let's say earlier you have 1, 2, 3, 4. And then assume that 2, 3. I'm just putting, this is absolutely wrong, because a stretching would make it differently, just to give you. So all you need to do is, now wherever there is 1, you need to replace it with 2. Wherever there is 1 in the original one. So with this, you know the mapping. So F old, you know, and F new, you will know, right? Or this, or let me put it this way. For a given F value, Okay, let me call this as this is equal to G. Okay, don't calculate every time. For if you have 100 by 100 pixel, there is no need to calculate it 10,000 times. Rather, you know, like there are only 255 possible values. So look at each pixel value, and you could have a simple 255 vector. That vector, okay, I'm telling you from the implementation point of view also. Let's call this vector as G. So here your index could be the original value. G of 1 should give you the new value here. Okay, that way you write it. And now in your image, I of G of I index, if you have an index here, you could something like that, you could do it. So G of I, the intensity value, you take it for that particular G of value, G of, or maybe f of x comma y would give you the intensity at that location. You write things in this array, and in the output, all you take to do is G of f of x comma y is what you need to write it at. Let's say new image is f new of x comma y. Okay, I'm scribbling something, but I hope if you are following my coding style, you would understand it clearly. Otherwise, don't worry. You just keep that expression in mind and do it. Am I clear? Any questions here? Okay, if there are no questions, so this is all we covered now. Okay, this is the only thing I had to add on to what has been already taught in the course, and this is the expression. That's how you will get the new value corresponding. Your f could be the index of this matrix here, or maybe 0 you need to handle carefully where it goes and all. Otherwise, this is one way of implementing. You do it in your own way. Okay, any questions?
So in the first question,
Right.
we were not given any scaling factors. So what are we? What should we do
Figure
about
it
that?
out, yeah. I told you how to work out the scaling factor, right?
So I was a little late to the class, sir.
You can watch the video. It's very, see, finally you want the values also in between 0 to 255.
Yes, sir.
So work out C such that the range still be in 0 to 255. As simple
Okay.
as that.
Okay, sir.
So you know what is the maximum value of R, for example. R to the power of gamma, what is that value it is going to give, right? That should be 255, not more than 255. So you accordingly work out what is the scaling there.
Okay, sir.
Got it? Any other question? Okay. So if there are no more questions, I'll let you work on your program now. This second programming assignment you can work out. If you have any further questions, maybe this chart is not necessary. I think Vaishnavi, in what way would, and Sindhura, in what way do you guys prefer? They can probably send you in chat, right? That's how you would perhaps prefer.
Yes, yes, sir.
Yeah. No need to immediately rush also. Enough inputs are given right now to you students. Okay. So in that, you also, as I was mentioning earlier, put some effort on your own. Okay. Everything also don't rush to Google to find out that. Many of the things, if you keep thinking on it, so once the hints are with you, if you think a little more deep into it, contemplate a little more into it, you will get all the things. Okay. Just it is enough if you have some hints around to like open the lock, then you just need, so that habit also should come out, not immediately looking for some source, but rather with the given information, can you yourself work it out? So try that out. Then if it doesn't, still some things are left, try Google things, go through any textbook, standard textbook, and see and figure it out. Then even if that doesn't work out, conceptually, if the doubt is there, you could even discuss with your friends, and then you can of course always come back to the TAs and also to me as well. Okay, so with that I'll stop here. Please go ahead. As I mentioned, dedicate this time. Don't give to anything else. 3 to 6 is fixed for image processing lab only. You cannot, you are prohibited to give this time to anything else. If you give, I cannot do anything. Of course, that's a different thing. But that's my appeal to you guys. You do it and you reap the benefits at the end. I'm sure. As I was mentioning, 15 into 3, 45 hours of time you would be spending on that. And that will definitely make you a very comfortable, put you in a very comfortable position when it comes to machine learning and this image processing part. Okay, I'll stop here then, if there are no more questions. Okay then, bye, take care. Have a nice week and weekend, and see you guys on Monday. Hope there is no more holiday on Monday. So see you guys on Monday. Bye.